Okay, so today we talk about the problem I left for the group before. Let's talk about this problem first. So see we have two point distance A and B. So Kevin is travel from the A to the B, then return from the B to A, and James is travel from the B to A, then return from the A to B. So now we have no. Okay, so we know at the first time, right? At the first midpoint, when Kevin runs to the A to B, and James runs from the B to A. This is the first mid location. We call the M1. Okay, the distance between the M1 and the A is 95. Okay, so now we know, and this distance is y minus the 95. Okay, so the other side is because A goes to B, right? Then return from the B to A, and for the James is running to the A, then return from the A to B, and the Kevin is to the B, then return from the B to A. So now they have the second meet time. I call the M2. Now we know the M2 to the B is 25. Okay, so this question is asking you what's the distance between the A and B. So there are two solutions. So the first solution is the make equation. So let's find some invariant here. So the invariant is the Kevin speed ratio to the James speed. The ratio is a constant. So because they travel when they meet, they both travel at the same time. So now we can see at the first meeting time, the Kevin travels 95, James travels y minus 95. So the distance ratio is their speed ratio. That's first equation. And let's see on the second meeting time. So on the second time, so the James is travel from the whole y and return. There are 25 kilometers short to make the 2y. So James is travel 2y minus 25, and Kevin is running from the whole y and return with the 25. So Kevin running the y plus 25. So this ratio is also equal to the Kevin speed divided by the James speed. So based on this, you have an equation of the y, and you can make when you solve the y, you can see y equal 260 kilometers. Okay, now this is the equation. Let's talk about the second solution. The second solution will be more interesting. Okay, let's talk about here. There is another invariant here, and I want to talk about. So we can see, okay, the first time when they meet at the first time, right? So the distance that the Kevin travel plus the distance of the James travel is equal to the y. That's here. Okay, when they meet on the second time, right? So let's expanding this one as this. So for example, this is the point B. Okay, let's expanding this one as just the return from the B to A. Let's expanding this point B to A, right? The A to B, expanding this segment is from the A return to B. This is B return to A. Now we can draw everything on the same line. So the first meeting time is here, right? And the second meeting time, so we know it's Kevin travels to the B, then return, right? Then it should be 25 kilometers passing the B, right? And also, so the Kevin is, the James is running the 25 kilometers close to still to the B. So this point and this point, when you fold together, is this point. So now we can see, okay, the Kevin and the James on the second, when they meet on the second time, the James is running the 22y minus 25, and the Kevin is running the whole y plus the 25. So the total distance they are running is 3y. So the first time the total distance they are running is y, the second time they are running is 3y. That means when they meet the second time, it takes 3 times longer, right? 3 times period against compared with the first time. What does it mean? Means the Kevin, the 1t Kevin running the 95 kilometers, right? Okay, so the second time they running the 3t, right? So here is the distance here, okay, is 3 times the 95. Okay, so we have the 3 times the 95 equals the whole y, that's here, from here to here, the whole y plus the 25. That's why we can make another equation is 3 times 95, okay? Then minus the 25 is equal to the y kilometers is equal to 260. Okay, so this, I think this is a much better way to see it. So the first meet time is t, the second time meet time is 3t. That's about it. Thank you.